equal to mass m1, and v square is what? Velocity dimensional formula. What the dimensional formula of velocity?
T minus 1.
L1 t minus 1 square divided by radius. Radius is L1. So the final expression becomes m1, then here L square. Okay, let me write everything. So L2 t minus 2, then L1 t minus 2. You get the same? Is it clear?
Yes, sir.
Okay, so these 5 questions I have given or more?
Sir, only this way.
Okay, only this 5.
There was another question also.
What is that?
Sir, name the physical quantity having unit but no dimensions.
Sir, but
That
you told
question.
it is solid and plane angle.
Sir, angles.
At the end, yes, yes. We have discussed solid angle and plane angle, and how it is. That also I have told that for plane angle, solid angle, we have imposed a unit. But from the formula point of view, you see, it should have no dimension and also no unit. But we have imposed a unit for the sake of convenience. Okay. Okay, so today we will discuss applications of dimensional analysis. Okay, so let us go for applications of dimensional analysis. Student is there. Okay. So today, how many students have joined?
Sir, 26.
26. Okay. So right, applications of dimensional analysis. See, first application to check the correctness of and to check the correctness of the equation, or you may say check the correctness of a scientific equation or relation. To check the correctness of a scientific equation or formula, you may say scientific equation or formula. Is it clear? First application, one application I will say and we will discuss it. Then we will go for the other application. Basically, we discuss 3 applications in this case. Okay, to check the correctness of a scientific formula or equation, we have to know, we have to use a principle, that is, this is called principle of homogeneity. So all of you write, this is called principle of homogeneity. Principle of homogeneity. See, homogeneity means equality. So principle of homogeneity states that the dimensional formula of all terms in both LHS and RHS of a equation must be same. Okay, right, all of you write, it states that the dimensional formula of each term in both LHS and RHS of an equation, in both LHS and RHS of an equation must be what? Same. Is it clear?
Yes, sir.
So dimensional formula of each term in both LHS and RHS of an equation must be same. Okay. For example, suppose A plus B is equal to C plus D. This is an equation. Okay. A plus B is equal to C plus D. Suppose this is an equation. So according to principle of homogeneity, dimensional formula of each term in both LHS and RHS must be same. Okay. So in the above equation, in the above equation, so dimension of A must be equal to dimension of B must be equal to dimension of C equal to dimension of D. Understand?
Yes, sir.
Okay, so there is another way of stating the principle. You just mark here A is added to B, C is added to D. So this they have same dimension. So we say physical quantities having same dimension can be added or subtracted. Make a note and write. Okay, make a note and write. Physical quantities, physical quantities having same dimensional formula, having same dimensional formula. Okay, physical quantities having same dimensional formulas can be added or subtracted. Can be added or subtracted. Is it clear?
Yes, sir.
So this is the principle of homogeneity. Now let us see how this principle of homogeneity help us to check the correctness, validity of a scientific equation. Hmm. Mm, one example. Yeah. Example one. Suppose you tell me any one familiar equation we have read in kinematics: B is equal to U plus AT, S is equal to UT plus half AT square, B square minus U square equal to 2S. Okay, let us for the sake of simplicity choose this equation. Suppose S is equal to UT plus half AT square. Let us see this equation is dimensionally correct or not. Okay. And I hope all of you know the meaning of the symbols used in this equation. Yes or no?
Yes, sir.
Yes, sir.
S stands for
Displacement.
Displacement.
displacement. U stands for
Sir,
Initial.
initial
initial velocity, T time,
velocity.
x. And A is acceleration. Okay. Now LHS. I have told the statement that each term in both LHS and RHS of an equation must have same dimensional formula. So LHS only one term is there, displacement. So dimension of formula of displacement is what? L1. So we have written LHS over. Then come to RHS. Now RHS, how many terms are there? Two terms are there. We have to find the dimensional formula of each term separately. So UT dimensional formula. So U dimensional formula is what? What is the dimensional formula please?
Sir, L1.
L1 T minus 1.
NT minus 1.
Then T1. So the final becomes L1. Is not it? T minus 1, T plus 1. Cancel out L1. So dimensional formula of UT becomes L1. Is it clear?
Yes, sir.
Okay. Then half a T square.
Sir, can you take the copy a little bit up?
Yes, please. Yes. Hmm. Okay. So half a t square and half is a numerical constant, so it has no dimensional formula. That we ignore. Only a t square. So a is acceleration. So what is the dimensional formula of acceleration?
Sir, L1 t minus 2.
L1 t minus 2 acceleration. Then t square means t2, t1, t2. So the final becomes L1 only because t minus 2, t plus 2 cancel out L1 only. And what you have observed, DC displacement L1, ut L1, half a t square L1. So they have all the three terms have same dimensional formula. So this means the above equation is dimensionally correct. So therefore you should write since all terms have same dimensional formula, same dimensional formula, the equation is dimensionally correct. The equation is dimensionally correct. Is it clear?
Yes, sir.
So for any equation, first condition is this equation must be dimensionally correct. But here one important point, a dimensionally correct equation may not be actually correct. But a dimensionally incorrect equation is always incorrect. Do you understand?
Yes, sir.
A dimensionally incorrect equation means the equation is definitely incorrect. But a dimensionally correct equation may not be actually correct. Why? You just mark this point, half a t square. Hmm. Instead of half, you have written it 3 by 2, 5 by 2, 7 by 2, dimension is same only. But you know that s is equal to ut plus half a t square only. It is not 5 by 2 a t square. It is not 7 by 2 a t square. Got my point?
Sir, could
Do
you
you
explain
understand?
again?
Huh. You see, we have checked the correctness of this equation. Agreed or not?
Yes, sir.
This equation is dimensionally correct. But you mark the second term of RHS half a t square. Half is a numerical constant, it has no dimension. So this is not appearing in the dimensional formula. Instead of half, if somebody have written 5 by 2, 3 by 2 or 7 by 2, is the dimensional formula is going to be affected?
No, sir.
No. This means the equation will be dimensionally correct, but actually wrong.
Yes, sir.
Got my point? So, a equation which is dimensionally correct may not be correct, may not be actually correct, but a equation which is dimensionally incorrect is always incorrect. Clear? Make a note and write this. Very, very important. Okay. A scientific equation, a scientific equation which is scientific equation which is dimensionally correct, which is dimensionally correct, may not be actually correct, may not be actually correct. Okay, but a dimensionally incorrect equation is always incorrect. But a dimensionally incorrect equation, a dimensionally incorrect equation is always incorrect. Always incorrect. Is it clear? So have you written the points?
Yes, sir.
Hmm. Okay, so one example I have given. Let me give another example. Then I will ask you to do. Okay. So I hope all of you have written it correctly. Written or not?
Yes, sir.
So let me give second example. Example two. You just tell me one equation. Any one of you tell me one equation. I want to check it whether it is dimensionally correct or not.
Sir, V square
Is
minus
equal
U.
to V.
Hmm.
V is equal to U plus A.
B is equal to U plus 80. Another one is telling
F is equal to MA.
F is equal to MA. This is so simple. Huh?
E is equal to
uh,
MC square.
eh?
E is equal to MC square.
But
Sir, V square
P.
minus U square.
Uh, okay. B square minus U square equal to 2AS. Hmm. B is equal to U plus 80 also we can do, no problem. Somebody is telling something else, what FC square or something, what she is telling.
No, sir, E is equal to MC square.
That E is equal to MC square. Okay. Okay, you just look at this equation. This equation is also all of you are familiar with, yes or no? B square
Yes, sir.
minus B square equal to 2AS. All of you know it. B is final velocity, E is initial velocity, A is acceleration, and S is what? Displacement. Is not it? Then how to check the correctness of this equation? See, we have start like this, LHS. And in LHS, how many terms are there?
Two terms.
Two terms. So we have to discuss each term individually. So V square dimension we have to write. So V square dimension, V dimension is L1 T minus 1 square. So the final answer becomes L2 T minus 2. Finish. Then U square. The same thing because V is final velocity, U is initial velocity, and they have same dimensional formula. So it is L1 T minus 1 square. So that is L2 T minus 2. Finish. LHS. Then RHS is 2AS. Okay. Dimensional formula 2AS. Again, 2 is a numerical constant that taken outside. Only AS. Okay. So what is A? Acceleration L1 T minus 2. What is S? Displacement L1. So the final answer becomes L2 T minus 2. And what you have observed?
Sir, LHS equals to RHS.
Each term have same dimension. Okay. So since all the terms have same dimensional formula, the equation is dimensionally correct. Just mention that since all terms have same dimensional formula, since all terms have same dimensional formula, same dimensional formulas, the equation is dimensionally correct. The equation is dimensionally correct. So is it clear? I hope all of you understand this. Yes or no?
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. So now I am giving you. So all of you, I hope all of you understand what is principle of homogeneity and all these things. Okay. So I am giving you a question. Now you do. Now your turn. I have explained both the questions. I hope you will be able to do this. Principle of homogeneity. Huh? Um. Okay. So in the equation, some of you may have observed this equation or may not. Don't worry for that. Just use principle of homogeneity to find this. So P plus A by V square whole into V minus B is equal to RT. Okay, this is an equation. Is it clear? Uh, So in the equation,
Sir, can you repeat the equation?
P plus A by V square whole into V minus B is equal to RT. So find the dimensional formulas of A and B. Okay, here P stands for pressure, V stands for volume, R is gas constant, and T is temperature. Is it clear? A and B are constants. A and B are constants. So are you able to write the question? Is the question visible to you or not?
Yes, sir, it's visible.
Visible, no? Okay. You write now and try to do this. Use principle of homogeneity. Very easy. You can easily do.
Sir, what is R?
Gas constant. Universal gas constant. Or simply gas constant.
So, what is the dimension of gas constant?
Uh, that we can find in different way, but I think you don't need it. In solving this question, we don't need the dimensional formula of gas constant. Is it clear?
Yes, sir.
Your name, please?
Sir, Ashi.
C.
Ashi, yes, sir.
C. C what?
Ashi Sharma.
C Sharma.
Sir, but how will we solve this equation without the dimensions of R?
We have told na principle of what?
Homogeneity.
Use that. Think about it. You can do
Sir,
it.
but in that we need both LHS and RHS.
Hmm. In note, I have written something while discussing principle of homogeneity. Just go through that.
Yes, sir.
Sir, completed.
Completed.
Yes, sir.
Oh, some people have completed. Okay. And give some time for others. 1 2 minutes.
Sir, B stands for.
Okay.
Sir, excuse me,
Completed.
sir.
Yes, yes, yes.
Yes, sir.
Sir, B stands for
A
V
B
minus B.
V is volume.
No, sir, B.
B are constants. A B are constants. See, there is some confusion. When constants, don't think that constants means they may not have dimension. Not like that. Some constants have dimension. Some constants don't have dimension. Okay. For example, numerical constant don't have dimension, whereas like gravitational constant has dimension, spring constant dimension, gas constant dimension. Okay, so in this equation, A, B are constants, but they have dimensions. Clear? So are able to do?
Sir, could you
Some
please do
people
it?
have done.
Sir, could you please do it?
Okay, okay. So those who have done it, please check whether you people have done it rightly or okay. See, just consider what is a principle of homogeneity. Physical quantities having same dimension can be added or subtracted. Since P is added to A by V square, so P dimension must be equal to dimension of A by V square. Am I correct? Then only the addition is allowed. So A dimension by V square dimension. Is it clear?
Yes, sir.
Physical quantities having same dimension can be added or subtracted. Use this concept only. Then P is added to A by V square, so they must have same dimension. So this gives you dimension of A equal to dimension of P into dimension of V square. And you to know dimension of pressure. Who can tell me what is dimension of pressure? M1,
M1
hmm,
L1 T minus 2.
M1 L minus 1, T minus 2. Because force by area, pressure is. And volume is L3, square is L6, volume